I am so privileged today again this evening to welcome you to our today's class. And I have a question in a particular question paper in mathematics that was brought to some candidates in the year 2024, that is last year, in as far as Cambridge IGCSE is concerned, as our curriculum under consideration. And the question was saying that a particular examiner had two figures, and the first figure was a cylinder. And the examiner tells us that the cylinder has a radius x centimeters, and the height of that cylinder is given as 3x. And you are told that this same examiner has a hemisphere. Just trying to make a schedule. So a hemisphere is just half of a sphere. And you're told that this hemisphere has a radius, and this radius is given as 5y. So any distance from the circumference or from the boundary of that diagram to the center can actually serve as our radius. So you're told that the surface area of this cylinder is equal to the surface area of this hemisphere. Just look at that. So the surface area of the cylinder is equal to the surface area of the hemisphere. And someone tells that prove that x squared, so prove, and to give a proof to this. So you're told to actually give a proof that x, or you're told to show that x squared is equal to 75 y squared over 8. Let me take you through this question in form of the summary I've captured here. I've actually told you that there are two diagrams. The first one is a cylinder, and the second one is a hemisphere. And the first cylinder that we have here, as our first diagram, has a radius x and the height 3x. This hemisphere has a radius 5y. We are told that the surface area of this cylinder is equal to the surface area of this hemisphere. So you're actually told to show that x squared should be equal to 75y squared over 8. What do? Let's first write down the formula of calculating the area of this cylinder in totality. How do I get the total surface area of the cylinder? I'll first say pi r squared, the area of the top part, which is circular in shape, pi r squared. The area of a circle is obtained by saying pi r squared, plus the area of the bottom part of that cylinder, which is also circular. You can also be able to say pi r squared. Then we say plus this curved surface can have its area getting obtained by saying pi dh. Of course, pi diameter and then height. Then this total surface area of this cylinder must be equal to the total surface area of this hemisphere. I know very well that if I have a sphere, then the total surface area of a sphere is given as 4 pi r squared. So this is a sphere, spherical in shape, of course, and its total surface area is obtained by saying 4 pi r squared. So if it is hemi, to mean half of that, we are going to have 2 pi r squared. So I would always be able to take this as 2 pi r squared, then 2 pi r squared. This is a hemisphere, this is a hemisphere. When put together, they will give us what we call a sphere. So a hemisphere 2 pi r squared, another hemisphere 2 pi r squared. The total surface area of this sphere 4 pi r squared. So that means this is going to be 2 pi r squared. What about the top part, which is also circular? You can actually take it to be pi r squared. So in other words, you can say the curved surface of that hemisphere 2 pi r squared plus the area of the circular part, which is pi r squared. So that the surface area of the first figure, the cylinder, is equal to the surface area of the second figure, which is now a hemisphere. And you can begin. Of course, you have not been told anything about the pi. You can still retain the pi in our working. We can first even combine these two and have 2 pi r squared, because pi r squared plus pi r squared, that is 2 pi r squared. Then plus pi dh. The answer must be equal to 3 pi r squared. Why 3 pi r squared? We have 2 pi r squared and 1 pi r squared. That gives us 3 pi r squared. So we can be able to actually begin working out our question. So 2 pi times r. The radius of the cylinder is x. We shall have x squared plus pi times d. D stands for the diameter. So d is the diameter. So it means 2x, because the radius is x. So the diameter will be what? 2x. Because 2r is equals to d. So 2x then times height. The height of the cylinder is 3x. And that should actually give us also the total surface area of that hemisphere, which is going to be 3 times, of course, pi is to get retained, and times r squared. Our r for this hemisphere is 5y, so it will be 5y squared. Okay, so we are going to have 2 pi x squared plus, of course, 2 times 3, that is 6, then x times x, that is x squared, then pi, and that will be equal to 3 pi times 5y squared, because it was r squared, and our r is 5y, so we're going to have 25y squared. And we can just proceed from here. Okay, so we have 2 pi x squared plus 6 pi x squared should be equal to, of course, you can be able to come here and say 3 times 25. That gives us 75. So it will be 75 pi y squared. Then we can be able to combine these two, because they are like terms. So we shall have 8 pi, okay, x squared. Okay, that should be equal to 75 pi y squared. Pi is common on both sides. You can be able to drop it. Yeah, so we shall remain with 8 x squared, okay, should be equal to 75 y squared. I'll divide both sides by 8, then by 8, so that our x squared should be equal to 75 y squared over 8. And if the units were in centimeters, we could be able to say 75 y squared over 8 centimeters squared, and then x centimeters squared, depending on the units given in the question. We were told to show that. You've confirmed that. Actually, you can show that x squared is equal to 75 y squared over 8 if the surface area of those two is the same. Thank you so much for getting time to be part of us in this class.